So good afternoon, everyone, and welcome to our session this afternoon on oceans and climate. I'm just going to do some introductions, if I may. My name is Jeremy Galt. I'm from University College Cork, where I work in the MARI Centre, which is the National Centre for Energy, Climate and the Marine. And I'm delighted today to be representing GeoBlue Planet. I'm one of the co-chairs of GeoBlue Planet. I'm joined by some panelists this afternoon. So to speed things along, I've put their bios on the right-hand side of the screen as you look at it. So Joanna, Marifani, and Sammy will be joining me. And as it said on the description of the site, we're going to focus on the complex interactions between oceans and climate. For that, we're going to consider the impacts on ocean health in terms of pollution, pressure, and resources, but also look at the impacts on climate change. So for this, what we want to do is sort of highlight the role of geo monitoring these impacts and supporting climate action, and that's both mitigation and adaptation, but maybe reflect on the challenges and perhaps more importantly, and with your help, identify specific opportunities where geo can help to identify these challenges. So because of that, Joanna will focus on the sort of the need for ocean observation. Marifani will then demonstrate some of the current and future observation programs. And then Sammy will present some applied examples to see how the information could be applied to address some of these challenges. So for this to work, we need your participation. So as I hand over to Joanna, I would encourage you to post questions and comments as we go along. If they're specific to one particular speaker, can you indicate this? So just put at Joanna, at Sammy, at Marifana, etc. After the presentations are finished, we'll hopefully have around sort of 20 to 25 minutes of lively debate. And at the very end, then hopefully we can identify 3 or 4 new opportunities for GEO with your help. Thank you. I'll just hand over to you and then to you, Joanna, please.
Thank you very much, Jeremy. Hello, everyone. Pleasure to be here. I'm going to share my screen. Okay. So I work at the United Nations Framework Convention on Climate Change Secretariat. I'm the lead there on research and systematic observation and also on ocean and climate nexus. And today I'd like to talk to you a little bit about how the ocean and climate nexus is important for the UNFCCC and how it's currently addressed and where we're going forward. So a little bit about the UNFCCC, the convention itself and the Paris Agreement, the importance of observation, and the importance of observation for a number of reasons. Primarily, we want to, of course, understand the state of the ocean, to monitor and understand what's happening and what the impacts of climate change are doing and what is happening in the ocean. But we also, the ocean is a space for solutions as well, for mitigation and adaptation action. And so we want to be able for observation to support that and to support understanding of how action is changing over time and influencing the ocean over time. I'm a big fan of this picture from NASA, which was taken now almost 50 years ago. At the time, carbon dioxide levels in the atmosphere were 330. This year, they've peaked over 410 ppm. So in those 49, 50 years, there's been a serious impact of emissions into the atmosphere. The heat generated by those emissions has been, as we all know, risen global average temperatures, but most of that heat has actually gone into the ocean and raised the temperature of the ocean quite severely, causing ice melt, causing changes in ecosystems, causing a number of other issues, sea level rise, and so on. So there's been a real impact of climate change on the oceans. And this is something that's really being addressed, but not addressed in a comprehensive way under the UNFCCC. So the UNFCCC recognizes that the climate system is a combination of the whole that you see in this picture, the atmosphere, the earth, the ocean, the geosphere, the biosphere. The UNFCCC also recognizes that parties should promote sustainable management and promote and incorporate conservation enhancement as appropriate of sinks and reservoirs of greenhouse gases, including oceans. And then the Paris Agreement in 2015 also recognized the importance of ensuring the integrity of all ocean, all ecosystems, including oceans, and the protection of biodiversity. So there is an understanding by parties that we need to look after the ocean. But the Paris Agreement is really a combination of commitments from parties. And those are through nationally determined contributions. And at the moment, there is some recognition of the importance of action in the ocean by some NDCs. Parties at the minute are providing their statements of intent around what they want to do under the Paris Agreement to reach the goals. And those goals are to limit global average temperature to well below 2 degrees C by end of century, to enhance adaptive capacity and resilience and low emission development, and to support finance compatible resilient development and low emissions. So that's Article 2 of the Paris Agreement, and the rest of the Paris Agreement is really about how that is happening in terms of mitigation, adaptation, finance, and so on. And the NDC identifies what parties want to do, statement of intent under the Paris Agreement. And then those statements of intent obviously need to be implemented. So mitigation action needs to take place, reduction of emissions, adaptation needs to take place. And for many countries, many developing countries, that's through national adaptation plans, NAPs here at the top left. Under the Paris Agreement also, there will be, or under our convention as a whole, there's a very strong push for reporting. And the Paris Agreement is a new way of reporting. It's through an enhanced transparency framework. So all parties will be put on the same level under the Paris Agreement to provide reports every 2 years, starting in 24. At the global level, under the Paris Agreement, it has a ratchet mechanism. So every 5 years, there will be a global stocktake, the first in 2023, and every 5 years after that to look at where we are in terms of aggregated progress on adaptation, mitigation, finance, and other things. And then from that process, there will be a push back to parties at national level for them to increase ambition in their nationally determined contributions and so on. Of course, action at national level is supported through a number of financial mechanisms, through technology transfer, through capacity building, and so on. But this is a cyclical process, the Paris Agreement, which is just starting. But it's also important to recognize that the ocean is an important part of all of this work. It's an important part of really being, to this date, the biggest buffer of climate change we've had. But we know that that is changing. And we know that there's some serious work needed for emissions reductions to protect the ocean. We know that the ocean is also a space where action can happen in terms of mitigation, such as offshore, such as emission reductions for transport, such as blue carbon ecosystems, where resilience can happen. The coastal zones, for example, will be the melting pot where all of this takes place because they're within national borders. So nations themselves are responsible for their action there. But they also need to protect their borders from the impacts of climate change. So this is really the opportunity for countries to bring ocean action into their nationally determined contributions right now and to build that in terms of action moving forward. And for the finance mechanisms to really understand the need for supporting that action that's identified by developing countries. Observations have a massive role to play in all of this work. They are the foundation on which we understand climate change, and the foundation on which we decide how to address it. And so there's really, the Secretariat works very closely with GEO, with WMO, with CEOS and CGMS, and with GCOS. So there's GCOS, of course, provide the essential climate variables definitions that a lot of the long-term data sets are based on in terms of climate change, but there's a lot of work in terms of just getting those basic observations that are needed to support the process. And those need to be strengthened, of course, moving forward. That observation feeds into research. Of course, there's the understanding, we have historical records, which of course are important. And then of course, research and modeling helps us understand what's coming Coming next, the impacts, the risks that are coming under different future scenarios, depending on the amount of emissions that are coming out. The IPCC is an important part of the UNFCCC process. They are there assessing all of the peer-reviewed science that's available. And then that information all feeds into, I would say, a policy black box, but in this picture is a policy pale blue box, and at different levels. So the information feeds directly to parties, as I said, to support them make the right decisions about climate change, mitigation and adaptation. But it also supports the negotiation process itself to bring in that information at the intergovernmental level, so that there's a conversation around what is available and what is needed, where are the gaps, what are parties needing. And there's also a conversation about the opportunities that are available under the Paris Agreement for the systematic observation community to support the global stocktake and understanding where we are in an aggregated way. Particularly, ocean is a very important part of that. So, as I said, observations are important for understanding the state of the climate. I've just given some examples here. The GCOS climate indicators, which are reported by the WMO State of the Global Climate Report directly to the UNFCCC on an annual basis, identify where we are in terms of physical properties, and 4 out of 7 of those indicators are ocean-based. The Earth energy imbalance, of course, is really, there's been a lot of research on this recently, and a recent paper came out by Corinna van Stroekman, looking at the fact that, you know, all of this energy is still absorbed in the ocean. We're not at an equilibrium, so we know that that energy, until that energy balances out in the Earth system, we're going to see continued effects, continued sea level rise, and so on for, you know, decades and centuries to come. So that we need to understand from observation the physical impacts. We need to understand the biogeochemical ones. One important issue that's coming up very strongly in terms of impacts in the ocean is deoxygenation and its effects. And then we also need observation to understand what's happening in ecosystems. For example, the blue carbon ecosystems shown on the map here on the bottom right. Parties also need to understand and have information, observation information to help them make decisions about mitigation, about adaptation, about early warning systems. So here, I just wanted to give a brief illustration. Recently, the High Level Ocean Panel identified that action in the ocean on mitigation could provide up to 20% of the mitigation needed to see us to a 1.5 degrees C temperature limit. That includes offshore, includes action in reducing emissions from domestic shipping and international shipping. It includes blue carbon. It includes more sustainable fishing. And a more controversial one, it includes storage of carbon in the seabed. But there's a lot of research to go on that. We also need science to help make decisions on adaptation. And there's opportunities also moving forward to really look at how observation can identify indicators to look at progress, particularly around adaptation, and to track progress, which is needed in terms of for countries to look at collective progress moving forward under the convention.
You've got 1 minute, Joanna.
Thank you. I can do it in 1 minute, it's no problem. So most recently, last year, we had a dialogue which was mandated at the Blue COP in Madrid in 2019. And last year we had an online dialogue to really look at how can ocean better be addressed under the UNFCCC process. A number of issues came out from that, the importance of strengthening action, breaking down silos at the minute. It's obviously an important part of the science conversation under the UNFCCC, but not so much a part of the policy conversation in terms of talking about action as I've just described, as well as talking about the importance of climate finance being ocean finance and supporting developing countries in their ambition. So there's a number of issues that are going to be taken forward a little bit to COP26 and beyond this year, really looking at how to strengthen ocean action under the UNFCCC, break down silos, to recognize that, you know, we're working in a system here where you're talking about climate, you talk about ocean, you talk about biodiversity, and you talk about sustainable development, and that is all one conversation. They're not separate conversations. So the big push really to understand is that to protect the ocean, we need ambitious emission reductions. We need ocean action, where mitigation is combined with management for conservation and restoration of nature. The UNFCCC has a commitment by parties for $20 billion per year to support developing countries in their ambition. Recent conversations have looked at the suggestion for a stronger inclusion of ocean action under the UNFCCC process. And for observation, the importance of observation there is that it's a foundation for the UNFCCC process and for science-based action moving forward. And this needs to be strengthened. It needs to be financed sustainably, and it really is an opportunity to bring the ocean more closely into the climate change conversation moving forward. Thank you very much.
Thanks, Joanna. And if you can stop sharing your screen, we'll pass over to Maria Fanny. I know there's a question for you in the box, which you can address after the last speaker as well, if you want to look at that. Joanna, thanks for the questions. Please do bring in questions and comments as we go along. There are now over 90 people on board, so we should be getting a few questions going. So as we go along, if you can pop your questions into the chat, then we'll address those all when the final presentation is over. Okay, Maria Fanny, are you ready?
Hi, yes, sure. So I'll share screen. Just give me a second. Share screen. Share. Can you see my presentation? Yeah.
Yeah, you're good. Good to go.
Right. Okay. So good good afternoon or good morning or good evening, everyone. So this presentation is about different types of observations that we are currently using to observe changes in ocean physics and to detect and attribute climate impacts and risk to the marine ecosystems. So I will show a number of in situ and remote sensing observations that are helping us to improve our understanding of climate impacts on marine ecosystems. Especially, I'll give a number of examples, and towards the end, I'll present a slide with the objective to give some clues, some ideas on how we can make best use of these Earth observations to support and raise our ambitions in terms of NDCs, so nationally determined contributions for ocean-based measures in the area of adaptation and mitigation. So I'll present a number of what we call climate data records. These are time series measurements of sufficient length, consistency, and continuity to determine climate variability and change. So here are a number of examples of those climate data records that are key ones, looking at physical essential climate variables for the ocean: sea surface temperature, sea level, sea surface salinity, and sea ice. And using those climate data records, we've been able to establish that the global ocean heat content has increased at a rate of 0.9 watts per meter. About 93% of the excess heat created by human activity ocean, and this heating effect contributes to about 40% of the global sea level. So waters expand when heated, and the total global sea level rise from all effects, including melting of glaciers, has led us to continue increasing sea level at a rate of about 3.3 millimeters per year. And since 1993, there has been sea ice extent loss of nearly 750,000 kilometers square per decade. That's about the equivalent of losing over 3 times the area of the United Kingdom every 10 years. So this is enormous. So these are some examples of what those key climate data records have been have allowed us to observe and detect, and some further applications on this. So these climate data records are used for model evaluations. So looking at physical conditions, I've given some examples, and also looking at impacts on ocean ecology and understanding the mechanisms of those impacts. And so I'll move on to more on ecology, so marine ecosystems. In terms of observations, ocean color are providing what we would call the biological climate data records for the world ocean. And one of the key products that we can retrieve from ocean color is the concentration of the pigment chlorophyll, which gives us estimates of the abundance of phytoplankton living in the surface of the oceans. So these phytoplankton cells, they carry out photosynthesis, which is a primary source of energy for the marine food chain, and they contribute to the uptake of nearly half of the CO2 emitted to the atmosphere every year. So phytoplankton really are key players both in the planetary carbon cycle, and they have a very strong societal relevance. So looking at trends from this ocean color climate data record during the past 2 decades, we've seen some significant trends at high latitude in the Arctic, North Atlantic, and other regional trends that have been significant, looking at a decrease in some regions, such as in the Pacifics. However, time series of chlorophyll, only about 2 decades, the results have to be seen more as evidence of climate variability during the study period, rather than evidence of really climate change. So these climate data records have been used in combination with in situ and model observation, and they've permitted us to assess some impacts, important impacts, which have been reported in the Ocean State Report that have been led by Karina von Schuckmann, and the IPCC special report on the ocean and cryosphere that was released in 2019. So in terms of key impact, climate change is causing marine heat waves to happen more frequently and with more intensity. The long and short-term ocean warming results in loss of habitats and mass mortality across ecosystems, and this also results in economic losses and food security issues for the society. So I'll go a little bit more quickly through an example looking at the El Niño climate phenomenon, which is characterized by an anomalous warming, I think you can see my mouse, of the sea surface temperature in the equatorial Pacific. And the perturbation is induced by this climate phenomenon can affect the weather and environmental condition worldwide. So it happens in that region, but it has impact worldwide. And recently we've seen a marked variation between the location of this anomalous warming, so occurring more on the eastern Pacific coast or more towards the central Pacific. So what are the consequences associated with this is that we see a very significant, very different response in the primary production in those regions. We have a very strong decrease when we have an Eastern Pacific El Niño, whereas we see almost no changes, and even perhaps sometimes a small, towards more of a small increase when we have the other type of El Niño. So again, these have repercussion on the fisheries, important fisheries, for instance, anchovies, and we can see in some El Niño conditions a complete collapse of those fisheries, whereas during other El Niños, we don't see such a collapse. So these are very important information that we can derive, that can help us to potentially identify periods when we need to protect those fisheries to allow for a stronger recovery. And in addition to the ocean color data, in terms of observation, we've seen nowadays more recently observation at very high spatial resolution, so about 300 meters, with the launch of the Sentinel missions from the European Space Agency, started in 2016. And we have on those Sentinels a number of sensors that are dedicated to measure, again, ocean color, sea surface temperature, and surface topography variables. And the Sentinel-3, so ocean and land color instruments, they provide significant improvement when compared with the previous ocean color sensors, including an increase in number of wavelengths, wavebands that are observed, improved in terms of coverage of the global ocean. So now we have a complete coverage with the two satellites in constellation, so under 2 days, whereas before was about 15 days. And we have a complete overlap as well with other sensors, such as sea and land surface temperature. So it means that we can analyze in synergy both ocean color and SST observation.
You have 1 minute, please, my friend.
Okay, I speed up. So it's 1 minute. Is this correct?
Yes, 1 minute.
Sorry, I did it.
1 minute,
okay,
yes.
so I'm nearly there. So in addition to this observation that we are more at the surface of the ocean, we also have nowadays, building on to that existing upper ocean sort of network, observations that goes below the sea with, for instance, the array of the Argo floats, measuring profiles of temperature, salinity, but also biogeochemical variables with new sensors available for oxygen, nitrate, pH, chlorophyll, suspended particles, and lights that have been available. So since this program started in 2000, and we are now having nearly nearly 3,900 operational floats. So this allows us then to build a global ocean 3D, for instance, particulate organic carbon and chlorophyll, which are very useful. I highlight on the left a number of applications. Another example of applications, this time related to human health and the disease cholera, which is a waterborne epidemic disease that is caused by bacteria, Vibrio cholerae, that we find in the water. And these bacteria respond to a number of environmental variables. And for instance, we can use some of those climate data records in combination with clinical data, epidemiological data, and use artificial intelligence to analyze those data and then provide, for instance, cholera risk informations. So this is part of the GeoBlue Planet working group on Earth observation for waterborne diseases. And so my last slide. So it's about how some observations that I've presented so far can help to raise NDCs in the area of mitigation and adaptation and mitigation. So for instance, in terms of community-based adaptation, so we've seen that some of the products can help us to identify key areas of fish production requiring protection from fishing pressure to facilitate recovery after some of the specific climate events. In terms of ocean productivity, some of those observations can help us to identify changes in primary production under climate variability and change, and to improve our understanding of the variation in the carbon flux. And another area for adaptation, potential pollution reduction, improving risk reduction policies as well. So, for instance, develop the ability to map hotspots of pathogens and forecast high risk of area for certain outbreaks of diseases to enable preventive measures to be implemented and so reduce risk to human health. Thank you.
Thanks very much, Marie-Fanny. And if we could move on to Sami. Sami, if you could share your screen, please.
Can you see my screen?
Yeah, you just need to go to full screen, yeah. Perfect.
Okay, so good morning, afternoon, evening to all. It's a pleasure to be virtually here with you. So in the next 10 minutes or so, I will try and provide some information on the GeoBlue Planet initiative, and in doing this, give a perspective of how EO and the GEO initiatives can maybe support the policy and the science, and thereafter help establish some user-oriented information services for the ocean climate nexus we are discussing today. So, as some of you might know, Blue Planet is the Ocean and Coastal Initiative of GEO. It's a network of ocean and coastal observers, social scientists, and end-user representatives from a variety of stakeholder groups, including international and regional organizations, NGOs, national research institutes, universities, and government agencies alike. The network aims to bridge the gap between data and services to mainly deliver actionable information that supports informed decision-making towards reaching sustainable development. The initiative as such is an integral part of the GEO work program and cooperates with many other program initiatives and flagships such as NBON, AquaWatch, EO4SDG, and so forth. We work to bring together EO experts and users to develop thematic information hubs and toolkits, develop indicators where necessary, and produce best practices that develop capacity for stakeholders to use EO ocean and coastal observations for decision making. From a Blue Planet perspective, the aim is to bring together really the indigenous knowledge and expertise together with the EO science and technology to further develop capacity and knowledge required to respond to the local needs. One example of how the initiative engages with users is through targeted stakeholder workshops, where we come together to discuss requirements with decision makers and users, and thereafter try and co-design services. One of these workshops was held in 2019 in Guadalupe, and it was covering Earth observation and coastal climate services for small islands. It brought together stakeholders mainly from the Caribbean, but with representation also from the Pacific and Indian Ocean region, as well as providers of climate and Earth observation services. And the aim of the workshop was threefold. Recognize the common challenges and data needs of small islands in relation to risk reduction and climate change adaptation. Identify development needs for additional data services, and thirdly, identify useful methods for the dissemination of such services. This type of work is relevant for the ocean climate nexus as it can further enable the design of the national action plans that were referred to before, as well as monitor, report, and verify the nationally determined contributions. Further to this, we can also think that this type of work may also support the parties of the Paris Agreement, identify if and how they can submit more ambitious national determined contributions in the future. We know that adaptation to climate change is a key component of the Paris Agreement. There's a UNFCCC synthesis report on intended nationally determined contributions that has identified 13 key climate hazards that should be addressed for adaptation. And this was based on the number of times the parties themselves referred to hazards. And several of these require ocean and coastal observations for adaptation planning, including sea level rise, ocean acidification, coastal erosion, and saltwater intrusion, for example. So from a climate adaptation pathway perspective, coastal and ocean observations can support the goals of integrated coastal zone management, marine spatial planning, and blue economy implementation. I just want to mention that these climate adaptation pathways are all examples of adaptive management processes which share similar implementation cycles. And truly the synoptic capabilities of remote sensing have been successfully applied to many aspects of, for example, integrated coastal management, including the sectors of coral reefs, wetlands, water quality, public health, and aquaculture. In the next slide, I will briefly provide an example which is relevant to the fisheries sector. There's some studies that have shown that another major spatial shift of the tuna fishing fleets, similar to the one that was observed during the 97-98 El Niño event in the Western Indian Ocean, would have a really devastating impact on the small island developing states that have developed economies that are really strongly dependent on tuna fisheries. So the figure on the left, which is taken from the FAO Fisheries and Aquaculture technical paper on impacts of climate change on fisheries and aquaculture, shows a sketch of possible spatial shifts of the purse seine fishing fleets operating for tropical tuna in the Western Indian Ocean by 2100 under the highest CO2 scenario. So what we can see is that the main shift would occur towards the Southeast Indian Ocean and would result in a relocation of the fishing effort. The Mozambique Channel would remain partly suitable for purse seine fishing, and a new area would extend to the southern tip of Madagascar. So while this sketch is purely qualitative, it results from a system-based analysis which combines projected changes of parameters and stressors, which can be observed through Earth observation. And here I'm thinking about temperature, dissolved oxygen, net primary production, and so forth, which are then subsequently integrated with other information such as tuna habitat suitability and other operational requirements of purse seine with regards to the environment to inform on the potential impact. Jeremy and the organizers asked all of us to identify opportunities for further developing this ocean climate nexus. And when it comes to opportunities, we must look at the synergies with the existing programs and initiatives. And one such opportunity is the United Nations Decade of Ocean Science for Sustainable Development. Coordinated by IOC UNESCO, the Ocean Decade aims to stimulate and coordinate research efforts, mainly to support the delivery of information, action, and solutions, which are needed to achieve the 2030 Agenda for Sustainable Development. The vision, as you can see, is to transition from an ocean we have to an ocean we want. But what is interesting is that within this context, there were 10 challenges that were identified. And there is one specific challenge which looks at exactly enhancing the understanding of the ocean climate nexus and generating the knowledge and solutions to mitigate, adapt, and build resilience to the effects of climate change across all geographies and at all scales. The decade was launched back in January 2021. So we are at the very beginning. And just at the beginning of this month, the first set of programs and contributions were endorsed by the IOC. So I guess we have an opportunity here to engage with them soon within the context of the Ocean Climate Nexus relationship we are discussing today. Of course, this work is not something that can be done in isolation. There is the host of programs, initiatives, projects, organizations that are already engaged, and we need to foster and nurture new partnerships. This must be done both internally within the GEO work program activities, the GEO member countries, the GEO participating organizations, as well as with the many organizations, UN organizations that are in the UN Oceans Framework. But also with other stakeholders that may currently be outside the GEO realm. I have included some on the slide, but yeah, but this list is clearly incomplete. Given the strategic importance of working together with the UNFCCC, one additional interesting opportunity I would like to flag along the lines of what was highlighted by Joanna in the first presentation is the possible engagement with the global stocktake process. So yesterday I was carefully listening into a workshop which was moderated by Dorothy Herr from IUCN, and Joanna was one of the panelists. And it really occurred to me that the upcoming global stocktake process may provide a concrete opportunity where the ocean community can deliver tangible support and information products. Now, I don't want to go into the details of this, but I believe this is an opportune time to work together to better identify how Blue Planet, but all the other GEO initiatives can support this exercise in terms of mitigation, adaptation, and as well as the means of technical implementation. And here I mean the development and transfer of technology and capacity building. And clearly, again, reflecting on what Joanna was saying, one element which comes to my mind is the development of possibly of EO-based services to contribute to the whole blue carbon monitoring discussion that is happening. Is my last slide, Jeremy. I don't want to repeat what was already said by Mary-Fanny, but really like to stress that there's a lot of excitement also from an EO technological perspective. Following liftoff last November and after approximately 6 months spent in calibration, the most advanced mission dedicated to measuring sea level rise, which is Copernicus Sentinel-6 Michael Freelich, is as of this week fully operational. And accurately monitoring the changing height of the sea surface over decades is essential for climate science and policy making. So it's really good news. So just to conclude, I want to reiterate that by understanding the policy process, the binding requirements, and the different implementing mechanisms of the Paris Agreement, and discussing the needs at national level, GEO and all of its initiatives will be in a position to provide some real added value to support and deliver the climate services, the indicators, and other informations which are needed. That's it from me. Many thanks to all. Jeremy, back to you.
Thank you, Sammy. And if I could just ask the panelists to turn on their cameras again, please. There are a few questions here. We covered a lot of ground there. Well done to the presenters for covering so much in such a short period of time. I think one of the questions, if you go to your Q&A, at the bottom you'll see the questions there. Joanna, are you happy enough that you've dealt adequately with Bente's question?
If Bente's happy, I'm happy.
Okay, I'll take Bente's happy. We'll go there. And then from Derek, a question for Mary-Fanny, which you can read there, I'll read out anyway. Are there novel subsea data sets monitored to complement our understanding of oceans in terms of luminosity, sound, evolution, other? Could you provide some examples?
Hi, Jeremy. I'm sorry, I didn't hear the question and I can't see it in the chat. Could you repeat?
Click on Q&A at the bottom. Question and answer at the bottom beside participants, at the bottom Q&A. To the left of share screen at the bottom, there's a Q&A. There's a question. Okay. From Derek.
From Derek. Oh, I'm sorry, it's not showing. Okay, could you repeat the question? It was breaking when you said it.
Okay, are there novel subsea data sets monitoring to complement our understanding of oceans in terms of luminosity, sound, evolution, etc.? Could you share some examples?
In terms of luminosity, so I know if in terms of luminosity, not necessarily. I believe. I mean, we have. I presented some of the new sensors from the Sentinels, so that's related to ocean color, and I'm not aware of luminosity specifically. I'm not that I'm aware of.
Okay. Then there's a comment on a question for you, Sammy. If you can read that, can you read the Q&A, Sammy? Can you read that from Kathy? So maybe if you just want to respond to that.
Yes, hi, Kathy. It's a very relevant point about writing up the process and really sharing the way we work within the context of the Knowledge Hub. I mean, Doug is here as well. He's the Knowledge Hub guru. I think we have had quite a lot of discussion with the Geosecretariat about merging this work within the context of the Knowledge Hub. It is happening, and there's really a lot of synergies, and more interestingly, there's a lot of examples of how we have worked in the different contexts that we will be very happy to share within the context of the Knowledge Hub. So it's not done yet, but it will definitely be part of the effort, which is led by the Secretariat for sure. Yes.
Doug, do you want to come in there, or are you happy?
Yeah, no. Thanks, Jeremy and Sammy. For sure, the Geo Knowledge Hub will be the place to tell the world about applications that use Earth observations, and in this particular case, can find their niche in support of activities around the ocean climate nexus. The Knowledge Hub, for those of you who are not familiar with it, is a place that will provide all the information you need, from papers that describe methodology to code to data, and even to computing environments where appropriate, where you can reproduce a given application of Earth observation. So, for example, if we're looking at trying to monitor fisheries and how that is affected by changes in ocean currents or what have you, if there's an application that's developed, we can broadcast that, if you will, through the Knowledge Hub. So we're in the nascent phase now of the Knowledge Hub, and within a year or two, hopefully we can start to feature some of these types of applications.
Okay. And then there's a question, an anonymous question. I've heard discussions on the opportunity for a digital twin of the ocean to help us capture and understand the complexity and data in science. Could the panelists reflect on this opportunity and the value this brings? Fairly easy one there. Sammy?
Yes. Well, there's a lot of work actually being done in Europe through the Destination Earth program, but at global level as well on the digital twin concept. I am not a DTO expert myself, but what I can do is that I can freely give some information about a session which is happening tomorrow, which is actually on the UN Ocean Decade. I believe it's happening at 1 o'clock Central Eastern Time. And one of the endorsed actions of the UN Ocean Decade is exactly the implementation of the digital twin ocean. So for more information on the DTO, I would really recommend to sign in tomorrow for the UN Ocean Decade discussion and session as well.
Okay.
Can I also reply to the question by Dr. Nath about the Sentinel-6 altimetry data? Yeah, so the data is available, or is about to be available to download freely to everybody. If you need any guidance on how to do that, I would recommend you contact either EUMETSAT or ESA for this, and they will be very happy to help you out.
I'll come back to Mary Beth's question in 1 minute. I want to ask the question at the bottom that Louis Sellers put up about the biggest challenge in the ocean climate is the collaboration between organizations and global initiatives. Maybe Joanna, you come in on that perspective to see how the synergy can work between these various initiatives.
It is a challenge. I will agree with that one. I think Geo Blue Planet is doing some great work. So credit to Sammy and the team. The UNFCCC process in terms of action, the adaptation work is based around what are called the NAP process, the National Adaptation Plan process, where it's a very structured approach to planning, priority, action, and projects in countries at the national level. It's an open process. It brings in a lot of information. A lot of that, the basis on which those decisions is made is from scientific information. So there's an opportunity there really for GEO, and there's a lot of work, for example, going through the GEO-GLAM on agriculture information that could be then, used as the model. And I know colleagues in GEO are already thinking about this to bring the information from the observation community to really support national level, first of all, assessment and then decision making. Moving forward, of course, I think there's an opportunity to really bring people together around the global stocktake as a starter, because the information, let's say the information level that we have is certainly we know about the global indicators. We have information at an aggregated global level. I think there's a big change now coming from the observation community to support a lot more sort of higher resolution information that will go from national to local to really specific. But the global stocktake is a point at which we could come together, provide aggregated information on what do we know about the ocean in terms of science, but in terms of also action going on in the ocean and the needs, with examples, and really try and bring the ocean community together to provide information to the UNFCCC process around some of these thoughts, these ideas for indicators moving forward, to look at how we can measure collective progress moving forward and really push towards stronger ambition.
Okay. Then maybe Mary Funny, can you see the questions and answers now, Mary Funny? Yeah. So the question from Mary Beth on what mechanisms can GEO leverage to be the vector for ocean climate change impact information to member states, EU member states, that is, so they can take action at the national level. Do you have any thoughts on that, or any other panelists if you don't?
Okay, yeah, maybe I still can't see the question. I think is this a question with regard to science policy?
I've pasted it into the chat if you're. It's in the chat
okay.
now.
Okay. To is effect or climate change impact information. I think on this, I see actually to potential, well, so for instance, some of the applications that I presented, I think this one, I mean, such applications, whether it's for information on the environmental conditions, the risk for fisheries, periods when, for instance, we might reduce fishing pressure, or the development of early warning systems for not just for climate services, but also for instance, climate-sensitive diseases such as, for instance, cholera. So this kind of application, I think this is where GEO could help to bring in this kind of application at the national level. So not just indicators and not just providing SST or sea level, or not just those products. I mean, going beyond that, going more into the applications.
Okay. Then there's a question to all from Michael. Can the Knowledge Hub provide the observational data / products needed for the ocean, more generally climate monitoring, or the users have to go to sources directly, NASA, etc.? Any thoughts on that? Sammy, maybe? Or is it Doug?
Well, I'll take a stab at it. The Knowledge Hub is, the added value of the Knowledge Hub is that you have all the components presented to you in an open science context, so that you can take an application that uses Earth observations to solve some particular problem and apply it, either scale it up or apply it in a different geographic region. You can tailor it to your needs. So the Knowledge Hub indeed can provide all the information that you need understand, to reproduce, and to apply a given solution using Earth observations. The users, if we're talking about actual data, for example, the Knowledge Hub is not going to be a repository for space data. It's going to tell you what data sets were used and then tell you how you can access those. If you're looking for the entire information chain, that's what the Knowledge Hub would provide you. If you're looking for specific components, then you would be shunted off to the appropriate place.
Okay, so combination thereof. Okay. Then at the bottom is a question from Shannon, which I'm going to point towards you, Joanna, if I may. As I'm putting in the science policy interface area. And maybe you could have a stab at that if you don't mind. Maybe we can learn some best practices from other aspects or other parts, other research areas, and how they integrate their data into other things.
Yeah, it's a tough one actually. The ocean space is so multi-layered in terms of the number of UN organizations with the policy in there. So UN DOLAS, of course, the Ocean and Law of the Sea Convention really has the legal instruments for how things operate in the ocean in terms of understanding where EEZs lie, and then IMO obviously deals with the shipping, FAO and others, and WTO deal with fishery. So and UNFCCC, of course, is climate change. And the reason, in some ways, that the ocean has not been dealt with under the UNFCCC so strongly is it's a country-driven process. It started off as emissions reductions as a priority, which was naturally thinking about those emissions reductions on land. And then, of course, with the Paris Agreement, adaptation became equal to mitigation in terms of urgency. And those are now both being addressed. And really, even now, there's been a move towards greater recognition of ocean under the process, but it's still moving it's moving in the right direction, but it's not quite there yet. So what can really strengthen this, and there's been a big push for this under the Paris Agreement, is the nationally determined contributions are this statement by parties of their intent to address their contribution to the Paris Agreement, which is a legally binding treaty. So there's been a big push for countries to bring in ocean related issues in their NDCs, which then is a point at which this science policy information can be, or the needs can be recognized, and then pushing the opportunities for science to support that conversation within the mechanisms that are there. At the same time, the UNFCCC, in terms of science policy, we work very closely with IOC as the lead UN organization on ocean science and ocean observation, because they obviously, of course, do a lot of work through Goose. They lead the work through Goose, sorry. And so the science policy conversation is also one that needs a lot more work, but it needs a recognition that there's enough information to start from, but there's also a need to push this science to support the big decisions that need to be taken right now, and to better understand how science can be applied for these decisions moving forward. So the UN Decade on Ocean Science Sustainable Development is a big move in this direction. We're talking about a seminar that we were both at yesterday, and colleagues this week at IOC are very busy with their executive council, but there's a lot of work around the UN Decade that can really push the science policy conversations forward. So there needs to be a recognition at national level of the links between ocean, climate, biodiversity, because these are often siloed. And there needs to be links across the UN process, which is also siloed according to conventions. Our sister convention, CBD, talks about biodiversity, but of course, their post-2020 conversations are about targets. Many of those are ocean-based. So that could be recognized also as indicators under the FCCC process. And then, of course, there's science to support all the decision-making and needs around this action within the ocean space. So the way forward that's often underutilized is the opportunity to talk to each other like we're doing now, to recognize what's there and what's needed and the gaps are there. So
okay, I'm under time pressure now.
sorry.
If I don't wrap up in time, they won't invite me back again. So it seems to me there's no lack of opportunities. And there's one last question which Sammy's typing the answer to on a technical question on altimetry data. But there's no lack of opportunities. It's just, I suppose, galvanizing those opportunities and working with the other partnerships, other communities to make sure that we're not duplicating effort. I do have to end, so I would like to thank the GEO for the invite to coordinate and this session on oceans and climate. I would, of course, like to thank the excellent speakers, the presentations, and the people from GEO in the background to make all this happen. I'll be working away in the background to make sure all the technology works and we don't fall over. But most of all, I'd like to thank all the participants for giving up your time and attending today. So thank you, and I'd like to close the session. Thank you.